Nice day. Welcome to the class of solid state physics. As you can see from the name solid state physics, what does it mean? It means the physics of everything which is solid. Everything that is happening in the solid state, you come and study and do research in this solid state physics. Some of the books of the solid state physics are also called as condensed matter physics. And when it is called as condensed matter physics, it is also having the liquid dimension. But we are not leaving away the gas, because when we speak in the solid state physics about the free electron theory, you treat these free electrons as gas, and in the law of a gas, we use the kinetic theory of gases though. And I would say this solid state physics is also called as a kind of a linking subject between the basic physics which you've already studied and linking it with the basic physics which you study, the basic physics which you studied in quantum mechanics, in classical mechanics, and you're taking it to the higher level, the actual level, the living level. In that way, it is called as a kind of a linking subject, whereby you are linking the physics we are studying in the classroom with the actual world, actually what is happening. So find a lot many kind of an approximations, the experimental diversions happening in this solid state physics, which will be very interesting to notify as we progress in this subject. So it is kind of a linking subject whereby you are moving from your basic physics to the research. The areas where we finish discussing the solid state physics will be all research topics. So while you study finish with the solid state physics, I hope and pray that you will be all good researchers. Now just look here. What I see is kind of a pattern. When we start our class, we used to always start our class with a kind of a diagram. We find interesting repetitions. Can you make out anything of it? A pattern is repeating. A pattern is repeating out. And just see a kind of an into mark which are placed here. These into marks are some specific point which I have abstracted out from this pattern. These patterns, these big ellipse along with the small ellipse, these two are the actual things. 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 Point. And by looking into them, we abstract certain points. Okay. And those points are the lattice points. These points are the lattice points. Lattice points. And these two things. These two things. These two things. These two things which you place on those lattice points. Which you place on these lattice points are the bases. Are the bases. So we have got a simple definition of a cell, or a simple definition of a crystal. Simple definition of a crystal. A crystal is basis placed on the lattice points. Basis placed on the lattice points. Sometimes instead of 2, you may have 3. You may have 3. You may have 3 atoms. You may have 3 molecules. Whatever unit you place as a basis on this lattice point gets itself repeated. It gets itself repeated. And you see the crystal structure. So, basis placed on the lattice point, you will have crystals. You will have crystals. So, crystals are nothing but basis plus lattice points. Or rather, you place this basis on the lattice points, you have the crystal. Now, what is primitive cell? What is unit cell? Just look into the crystal, you will find some basic blocks which are getting itself repeated. Those basic blocks which repeat itself, they are called a unit cell. Unit cell. You repeat the unit cell, you get the entire crystal. And what is this primitive cell? Or what is rather the difference between a unit cell and a primitive cell? Interestingly, the modern books doesn't make a difference between the unit cell and a primitive cell. They take the same concept as the same, but in the conventional books and older books, they make a kind of a difference between the unit cell and a primitive cell. When they say inside a primitive cell, you can have only one lattice point. You can have only one lattice point. Inside a unit cell, you can have more than one lattice point. The rest of the things, same. You repeat the unit cell, you get the crystal structure. You repeat the primitive cell, you get the crystal structure. For example, in order to make this concept of this lattice point more clear, let us come to a very small example. Okay, I've drawn a simple cube and I'm going to enumerate the number of lattice points that are inside this cube. You can find lattice points here placed over here. These are all the lattice points. And all these lattice points you can place the basis. You can place one item, two item, as you like, as I just said. I want to find out how many number of lattice points are inside this cube. How many number of lattice points are inside this cube? There are two different ways in order to find out how many number of lattice points are inside this cube. The first method is, what you have to do is, you have to shift this cube in x direction half this length. For example, if this length is a, what you have to do is, you have to shift this cube in this particular direction half this length, 1 by 2a. You shift it 1 by 2a. And after that, what you have to do is to shift in the upward direction, the same length, a by 2. Finally, either you have to push it in this direction or you have to pull it in this direction towards me in a by 2 direction. And if you do it, you will find there will be only one lattice point inside this cube. You get that idea? If you don't get that idea, you actually do it, what I said. Then you will find it out. What you have to do? You have to push it as you push it. For example, in this particular case, if you just push it down, if you just push it in this particular manner, what will happen? If you push in this direction, how many will be there? These 4 will go out. These 4 will go out. So push in this direction, there will be 4. 1, 2, 3, 4. 1, 2, 3, 4 will be inside this cube. Fine. Then you push it up. As you push it up, these 2 will be outside, but these 2 will be inside. Clear? Then if you push it in this particular manner, only this will be here. However, if you push it in that manner, that direction, only this will be inside. Hope you got that idea. There is only one lattice point inside this cube. There's another way how you can find it out. What is the contribution of this lattice point to inside this cube? The contribution of this lattice point inside this cube. In order to find it out, you have to think about how many cubes are sharing this lattice point. How many cubes are sharing this lattice point? For example, this one. How many cubes are sharing this lattice point? You can have one cube here. This cube definitely shares this one. You can have another one here. Fine. Another one here. Another one here. So the 4 on this surface and the 4 down. 4 beneath this one. Hope you got that idea. One this one, the second one adjacent here, the third one here, and the fourth one here, and similarly 4 1 down. So this particular lattice point has been shared by 8 such cubes, which means the contribution of this lattice point to this one, this particular cube, is only 1 by 8. Is only 1 by 8. So how many of them are there? 1, 2, 3, 4, 5, 6, 7, 8. So 1 by 8 into 8, which means 1. Which means inside this cube you have got one lattice point. Hope that idea is clear. So when you study about the cubic structures, you come across 3 different types of the cubic structure. The first cubic structure is simple cubic structure. The simple cubic structure, when you deal with the simple cubic structure, we find that inside the simple cubic structure, you have got one lattice point. And how the atoms are placed inside this is simple cubic structure. One atom will be here, the second atom will be here, the third will be here, The fourth will be here, fifth will be here, sixth, seventh, and perhaps in a bigger line, eighth. There's always a chance that these two atoms may also meet. They may touch each other. So in this particular manner, you can find as there is one lattice point inside this cube, we can also say that there is one atom inside this cube. If you place only one atom on this lattice point, but remember, I got the ability, or you can very well place not just one atom on the one lattice point. You can place two atoms on this lattice point. You can place three atoms in this lattice point. You can have 10 atoms on this lattice point. Okay? And the similar way, you can have 10 atoms on this lattice point. You can have 10 atoms on this lattice point. Clear? If you place 10 atoms on this lattice point, definitely you are going to have the 10 atom on this lattice point also. The basis consists of 10 atoms. Clear? Then in that particular case, you can say inside this cube you have got one lattice point, and one lattice point you have got 10 atoms. The second type of cubic structure is BCC, body-centered cubic structure. I'm going to draw the body-centered cubic structure now. Okay, it's nothing but the cube, and I got the cube, 5. My drawing is not that perfect, but as you can have the idea as perfect. Apart from that, we can also have the next one in the center. It's exactly in the center of this cube. Exactly in the center of this cube. So this is called as body-centered cubic structure. Body-centered cubic structure. The question is, how many number of lattice points are inside this BCC structure? How many number? 1 is fully inside this one. So it is 1 plus all these 8 constitute and make 1. As explained before in the case of a simple cube. So 1 plus 1 gives us 2 lattice points are inside the BCC structure. The third cubic structure which we are going to explain here is FCC, face-centered cubic structure. What are the lattice points? As I said earlier, these are all the lattice points. Apart from it, each face will have a lattice point. This is a face, the top face. There will be a lattice point here. Similarly, down face, there will be a lattice point here. And the 4 roundabout faces. One face which is looking at you, the center is this one. Looking at me, the center is this one. These 2 faces, the one face and the other face. Clear? So just count how many number of lattice points are there. Now to count the number of the lattice points, we can say there are 2 different types of lattice point here. First, on the vertices, they contribute 1 by 8 into 8, 1. All of them constitute and they contribute and they make 1 lattice point inside this cube. And what about the lattice points which are placed on the face? Look on this face, how many number of cubes they share? We know 1 cube, it shares half. There is another cube here that can share the half. In the same way, on the top, you can place another cube. So this lattice point, the half is shared by this cube. The another half will be shared by the other cube. So this will be half, 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 half. How many of them are there? There are 6. So it will be half into 6. Half means inside to this contribution to inside this cube is half, and in the similar manner there are 6. So half into 6 is 3. You add them, you have 4 lattice points inside this FCC structure. As a kind of an assignment, what you can do is you can try to find out The different types of the material as an assignment, the first thing is to find out the type of the materials which are crystallizing in the simple cubic, BCC and the FCC crystal structure. So the materials which are crystallizing in these types of structures, in simple cubic, BCC and FCC structures. 5. In the second case, you just read about and find out what is meant by atomic packing fraction. What do you mean by atomic packing fraction? APF. I say atomic packing fraction is the volume of the volume that has been occupied by the atoms divided by the entire volume of the cube. The volume that has been occupied by the atoms inside a cube divided by the entire volume of the cube. That is atomic packing fraction. In the next class, we will be deriving the atomic packing fractions of simple cubic, BCC, and the FCC structures. The third thing that you can study about is the different types of the crystal structures. The different types of crystal structures. The different crystal structures. The Google will give you a good treat on this subject. We call them as bravest lattice. We can find there are basically 14 different types of bravest lattices which form in 7 crystal structures. So as an assignment, you can study about these different types of the crystal structures. These unique way in which you can arrange the crystals. That is what I mean by different types of the crystal structures. So as a third assignment, you can study about the different crystal structures. Well, friends, the next class we will be deriving about the atomic packing fractions of the simple cubic, BCC and FCC is some other example with some of the worked out problems. Have a good day. Thank you. May God bless you.